Hello, this is Volka. I'm the game developer behind Kohlrabi Starship, and in this video I will show you how to create a hologram shader in Godot. And if you don't have any experience with shaders or Godot in general, no worries. We will create the hologram shader in 4 parts. First, we will colorize the texture such that it gets a blue tint like so. In theory, you could also have a green or red hologram here if you choose different colors. In the second step, we'll make the hologram wobble like this. In a third step, we are going to add these pixel distortions. And then lastly, we are going to add a strong distortion effect that will appear from time to time. The first 3 steps can be used independently of each other, so if you're just interested in one of them, there are the timestamps in the description. This video is sponsored by Brilliant, more on them later. And if you don't want to implement everything yourself, you can download the shader code on my Patreon page for free. The link is in the description. Alright, let's start. All you need for this project is a texture of a character that you want to turn into a hologram, and additionally, we need one specific texture for step 3, which is just a white square with some black pixels painted in. The more pixelated you want your hologram shader to be, the more pixels you can paint in here. But it's not a science, just throw in some pixels and paint and you're good to go. Okay, first we open a shiny new project and we import our image that we want to turn into a hologram. We create a 2D scene, add a node for a 2D sprite and add our texture. In the material settings, we create a new shader material and in there we create a new shader. It will appear in the folder overview on the left, where a new file was created for our shader. If we click on it, it will open this window where we can program it. You can see it already comes with a template for a shader, and this is where all the magic happens. We don't need the light function here, so we can just delete it. And we also don't need the vertex function, so let's remove that as well. What we do need is this fragment function here, which is computed for every pixel of our texture. So now we are all set and we can start the work. We use the default shader type canvas item here, which means we do some 2D rendering. There are other shader types for 3D and particle systems, but we don't need them today. We start with the first step of colorizing the input texture and creating a blue color gradient in the following way. We are going to convert our texture into a grayscale one, and then we map all these gray values to a color in a color gradient. Using a color gradient is super useful because it allows us to create a really vibrant hologram, which is much more pretty and interesting than just overlaying a single color here. Alright, so here I'm starting off by defining a float for our gray value. I will call this color BW. And BW stands for black and white, and then I will use a custom function which I will write in a second. I will call it RGB2V, so red, green, blue to value, and I put in the color RGB values. So let's look at this line here. We can see that color is written in bold uppercase letters. That means that color is a variable that is provided to us and that already has some information. There are quite a few of these different types of variables. Color provides us with the RGB values and alpha value of the pixel that we are currently working on. We will also be using UV, which gives us the UV coordinates of the current pixel we are working on, and time, which is the past time in seconds, and then lastly texture, which is the current 2D texture of our character. These are all super important for any kind of shader we want to write, so keep them in mind. Okay, let's go back to our shader file. We now have to write our custom function RGB2V, which converts the RGB color values to a single gray value. We can do this by simply averaging the red, green and blue values that we have. To display our single gray value, we can plug it into a color vector like this. We just have to make sure that the alpha channel stays the same as it was before. And here you can see we got this very nice gray image. If you are satisfied with this grayscale image, just jump to the next step. Otherwise, we can extend this a little bit to get a little bit more control over how much weight the red, green and blue channels will have in the resulting gray image, which is often also done in different art software like Photoshop. Therefore, we define 3 parameters now, which I will call tint alpha, tint beta and tint gamma due to a lack of creativity. I set them all to about 1/3 for now, which will give us the same result as before. And the hint range here tells the editor that you can adjust this shader parameter later between 0 and 1. We also have the uniform keyword here, which means that this variable is a shader parameter we can set in the editor and that it is global, so that it is the same for every pixel. Now you can see we can change the values to give different weight to the RGB channels. And to be completely fail-safe, because we can change these weights independently from each other and they don't necessarily add up to 1, we divide by the sum here. And now we have a bit more control over the grayscale image. Now we need to map the gray values to a gradient. For that we add another uniform. This time we use Assembler 2D, which can be used to read 2D textures, but we can also use them for gradients. The keyword source color here is very important to tell the shader that we are working with colors. It is important for proper color conversion. If we don't use it, the texture will appear washed out. In the shader parameters, we can now set the gradient parameter to be a gradient and define its color values. Unfortunately, the screen capture didn't capture the small color picking tool pop-up window, but you can still see the colors that I picked. In theory, you could choose any kind of colors you wanted here. I'm using mostly blue, but on the highlights I'm using a little bit of yellow tone, and in the darker areas I'm using a little bit more violet to make the whole image a bit more vibrant and interesting. Alright, now we have a nice gradient, but we haven't used it in our shader code yet. What we are going to do now is sample it. And for that we can use the inbuilt function called texture, which, as the name says, reads a texture. That might sound a little bit confusing since our gradient is just 1D and not 2D, but worry not, our gradient variable basically works as a 2D texture. This is a-okay and it's the first input we need. The second input here are the UV coordinates we want to read in our texture. They are always between 0 and 1. So x will be our gray value and y is just 0 because it's meaningless with a gradient here. And the output is a color from our gradient. But something went wrong with the alpha value, and that's because we are using the alpha channel from the gradient, where instead we need to use the alpha channel from our original input texture. So we can simply set this manually and you can see now we have a really nice blue tint to our image. First step done. If by now you feel a little bit uncomfortable by all this coding and a little bit out of your depth, don't worry about it, that's perfectly normal and I know what can help. Let me introduce you to this video's sponsor, Brilliant. Brilliant is where you learn by doing, with thousands of interactive lessons in math, data analysis, programming and AI. It's not just about memorizing a programming language, but actually learning how to problem solve, learning underlying concepts, and developing an intuition for coding, which is super useful, whether you code your game with GDScript, C# or write a shader later. Another feature I really like is that Brilliant is really easy to get into, and it encourages you to learn a little bit every day. Imagine how fast that adds up to build real knowledge. They have a lot of courses to choose from and they are adding more all the time. They also teach you foundations of math, which can be super useful for shaders actually. But most importantly for you, they have great courses to develop your mind to think like a programmer and begin writing complex programs to build games. To try everything Brilliant has to offer for free for a full 30 days, visit brilliant.org/volcadev or scan the QR code on screen. Or you can click on the link in the description. You will also get 20% off an annual premium subscription. Now, onward to the second part, We now want to add this horizontal wobbly noise to make it look like there are distortions that might be individual pixel lines of the hologram. This is not very scientific, it's just a little bit of art. We want to apply two different kinds of distortions here. We want to add a larger wobble that moves the whole hologram. You will see what I mean in a second. For that, we need noise, and the best way to generate some noise in Godot is to use noise textures. So we start by creating two uniforms again, which are both textures again. We use the keyword repeat enable here, which means that we can read it with UV values outside of 0 and 1, which will come in handy later. In the shader parameters, we can create a noise texture, and Godot already has all the functionality you need to create different types of noise, which is really amazing. First, you choose a noise texture, and then at the very bottom in the noise type, you can choose, for example, fast noise light. We also want to create a seamless texture here. Since we are going to repeat the texture, it needs to match along its boundaries. But otherwise, you can just leave all the parameters as they are, and then we are going to create a second noise texture, and here we adjust the frequency such that it's a lot more noisy than the other one. Okay, how are we going to use these two noisy textures now to make our character wobble? Basically, we are going to use the random gray values that are generated in our noise texture to move the pixels of our character texture a little bit to the left and right. To do so, we are first going to sample this texture again with the inbuilt texture function. Here we use the current UV coordinates and sample the noise texture at the same position. Sampling our noise texture gives us a 4D color value, but we can make our life simple and we just take the red value and use this as our offset. To make it look like horizontal wobbling, we only want to offset in the X direction, so I'm just calling this noise 1X. We add this offset value to our current UV coordinates and then read our character texture there. Which means that by doing so, we now display a pixel that's a little bit to the left or right of what we originally would have shown. We plug this into our existing tint colorization, and then you see, wow, this is really not like what we would have expected. The reason is that the distortion is way too strong. So what we also need is another uniform parameter that lets us adjust the distortion strength. We just multiply it here, and you see we just have a little bit of this wobble now. Now, of course you will say, this doesn't move at all. That's not what a hologram looks like. The trick now is to use the built-in time variable. Of course it changes with time, and we can use this to make our shader dependent on time. We add it here to the UV coordinates when we sample our noise texture. What this does is move the noise texture offset values across our character texture. Again, we want to be able to adjust how fast this happens, so we create another uniform, which is our scrolling speed. And we create two of them because we have two noise textures, and we want to be able to set the speed for them individually. At this point, we can add in the second noise texture. We basically do just the same with it as we did with the first one and combine them by multiplying their offset values with each other. To create a little bit more of a pixelated effect, we can play around a little bit with the type of noise that we use. If we use a cellular noise type, we can set the distance function to Manhattan. A Manhattan distance function is named after the rectangular streets of Manhattan and basically creates these diamond shapes instead of circles. That gives us a little bit more of a blocky appearance. There are all kinds of different types of noises, and you can play around with them and see what you like best for your hologram shader. Okay, alright, we're almost done with this part. We just need to fix the outline of our character texture again. You can see that it doesn't wobble quite right, which is because we are not using the correct alpha value again. But we can fix this, and now we have this really nice moving hologram. Okie dokie, halfway done, on to the next step. We now want to add blocky pixel distortions. We again start by creating a uniform for a texture. But this time we will use our handmade black and white pixel texture. We will enable repeat again, and we add another keyword here, which is filter nearest. Without going into too much detail, it basically means we don't average pixel values when sampling the texture. This is important to create very crisp outlines and reduce blurriness. Okay, let's divide the code we have already written into two parts, because in these lower two lines we want to later combine everything. We again need to sample our input texture here, and we will again sample it at the current UV coordinates, which will either give us a black or white color. Now in this next line I want to convert it to a variable that is either 0 or 1. To do so, I first convert the sample color into a grayscale value with the function that we have already written, which will give us a value of 1 for white pixels and a value of 0 for black pixels. We subtract this from 1 to switch it around, and this variable now works similar to a boolean, which tells us if there's a black pixel or not. We can use this for a trick, because we want to either distort our texture by Wobble, or we want to have a pixel distortion, but not both at the same time. For the pixel distortions, we simply offset the displayed pixels as if our hologram data was mixed up. So, here we have two lines. The 0.05 here is the simple offset for our blocky pixels, and the second line is the wobble we already implemented. We now multiply with our hasPixel variable like this, and since this is either 0 or 1, only one of the two lines here will ever be computed. What we can see now, even though it might be a bit hard to see in this video recording, is that the blocky pixel distortions, they are there, but they just slide across the screen from top left to bottom right. So we really need to randomize their location a bit to make it look better. For randomization stuff, we need noise. And so we add our last noise texture here. This time we use a very small texture of just 32 by 32 pixels, and we create a noise with such high frequency that we basically just get these completely random values. We use this texture to get a random offset in X and Y direction for each point in time, which means that we sample this texture twice, once in X direction depending on the time and once in Y direction depending on the time again. We just take the red value again as before, and then we use this to create a random offset 2D vector, which we can plug in here when we sample our blocky pixel texture. And you can see that now the blocky pixels move truly randomly across the hologram. Now let's add another parameter again that lets us control the speed with which these pixels move, and then we can play around a little bit with it to see what kind of effects we like best. Great, we are almost done. One last great effect to make it truly fantastic is to add these really strong distortions from time to time. You can see that earlier we added a variable that lets us adjust the distortion strength. Over time, I now want to crank it up quite a bit for just a moment. For that, now we do a truly hacky trick that lets us reuse everything we already have. We just take our existing blocky pixel texture and we sample it over time. And we are about to hit one of these black pixels from time to time. And whenever we hit them, we want to turn up the distortion strength. We use the same trick as we used before. We have a variable that is 0 or 1 and tells us if we hit a black pixel. And we multiply it with a normal distortion strength and a strong distortion strength like this to get one of the two. Now we need to add our strong distortion strength here too, so that we can set it. And then insert our adjusted distortion strength here, and that's it. You can see that sometimes we now get a really strong distortion effect. And this is the complete hologram shader. If anything was unclear, this was my first tutorial video, so please ask in the comments, I'm happy to help. Or you could join my Discord to talk about shaders there, the link is in the description. Also, check out my game Kohlrabi Starship. It's a cozy farming game with space travel, and you can already wishlist it on Steam. A big fat thanks again to my patrons for your support. I am really grateful. Happy coding, bye bye!